Hey guys, today we will simulate a simple harmonic motion of multiple balls using Vpython, and this is how the simulation will look like. So there will be 3 balls connected to springs during simple harmonic motion, and right here we will print out their instantaneous kinetic and potential energy as well as the average potential and kinetic energy. Okay. So for the simulation today, there are 2 essential parts. The first one is how to create a list of multiple items, and the second one is how to create a simple harmonic motion of a ball connected to a spring. So first of all, when do we need to use list? We usually use list when we have multiple very similar items that they have basically the same attributes, just the values are different. So for example, right here, I have the spring constant. So all 3 springs are very similar. The only difference is their spring constants is different. So I can just say K is 15. The first spring has a spring constant of 15. The second one is 12, and the third one is 17. And so this is called a list. Very simple. And the special thing about list is instead of the first, second, and third value, these 3 are the 0, the first, and the second value of the list. And for the initial velocity of the balls, I do the same thing. I create a list of 3 different initial velocities. Okay. So right here, I will establish a list named balls. And right now, it's still empty because I haven't put anything into it yet. And here we will see this for I in range 3. This means I will have I from 0 to 2, 0, 1, and 2. So let's take I is 0 for example. When I is 0, I will create a sphere object, and its position will be at L is the length of spring, will be at L plus D0. So D0 is minus 0.06. And the sides, which is its radius, and right here its z position will be 0 minus 1, negative 1 times 3 times size, and then the ball's radius and its color. As for the ball's initial velocity, it will be at v0, which is 1, 0, 0. And this line right here means I will add a ball object to this list named balls. So right now in this list I have 1 object, the first ball, or the 0th ball actually. And then for I is 1, it will do the same thing, but just it will replace di to be d1, which is 0. And v1 will be 2. And then it will add this ball to the list. So now we have 2 balls. And then for I2, it will do the same thing again. So after these, we will have 3 balls in this list named balls. And then we will do the same thing for springs. We will create an empty list of springs first. And then for I in range 3, we will create helix object. And this is its initial position and its spring axis. And the difference between the spring's position and the spring axis is that the spring position is the starting point of the spring. For instance, in our simulation, it is the point where it is connected to the wall. As for the spring axis is also a vector. It is more like where the spring is pointing to, like axis. So for example, if I have a vector AB, then the vector AB will be the position of B minus the position of A. So very similarly, because the spring axis will point from its starting point to where the ball is at, so it will be the ball's position minus the spring position. So let's take I as 0 for instance. For the 0th spring, its spring axis will be from its starting point to the 0th ball's position. And the spring K is its spring constant, so for the 0th ball, its spring constant will be 15. And then we will add this spring item into this list named springs. And then for I is 1 and I is 2, it will do the same thing. So after these, we will also have 3 different springs in this list. Okay, so now after we have created two lists, one is for the balls and one is for the springs, we will move on to the physical part. Oh, and one thing that you should keep in mind is that when you mention the balls, like you want to say the 0th ball, you need to add this S. It's not like this. This doesn't make sense because this means the 0th value in this balls list. So because the name of the list is balls instead of ball, so if you just write this, the computer will tell you that this list doesn't exist. Okay, so don't forget to add the S. Just basically, you just have to copy the complete name of the list. So right here we have this while loop, but what is different from previous simulation is this time the condition is true, and true means always true, so this loop will just keep going. Okay, so at every time the spring exits should always be from its starting point to the ball's current position, so that way the ball is always connected to the spring and the spring is always connected to the wall, if that makes sense. As for the spring force is proportional to the change in its length. So right here, let's look at this. In fact, the magnitude of the spring axis is exactly the current length of the spring. So the current length of the spring minus its initial length will be the change in the length. And you will notice a negative sign right here because the property of spring is that if the spring is stretched, then the force will tend to make it shrink back to its original length. And in the contrary, if the spring is compressed, the force will tend to make it extend back to its original length. So that's why there is a negative sign right there. And this is just the spring constant, the change in length. And right here, there is a strange thing right here. So, oh, this is cool. Okay, so because this spring axis norm, this one means its unit vector of spring's axis. Why do we need this? Because, first of all, force should be a vector. But this is a constant, and this is a magnitude. So these two multiply together, it will still be a magnitude. It will be a scalar instead of a vector. So in order to make it into a vector, we need to multiply it by the unit vector of spring's axis. So right now the spring force is a vector. So right here we're just using the Newton's second law of motion to calculate the ball's acceleration. So like, oh, right, I forgot to mention. So in this while loop, we will also use this for I in range 3. That means for every dt, I need to do the exact same thing on all 3 balls and all 3 springs. So when the code runs, it will make I 0 first and then get all the attributes for the 0th ball, and then I is 1 all the attributes for the first ball and then the second ball. So it will make sure that at any moment all 3 balls are moving as they should. So we will just acquire the ball's velocity and its position, just like what we did in previous simulations, so I will not go into further detail this time. And as for the kinetic energy and the potential energy, we just write down the formulas for those. So that basically sums up the code for today. It's quite simple. So let's take a look at it again. Yes, right here. So there will be three different items. So we create 3 different items using list. And then the spring axis, make sure that the spring is always connected to its starting point and to the ball's position.